We have a lot to cover and would like to allow time for questions, so we'd like to get started promptly now. My name is Paul Duane, and I'm a Strategic Planning Manager with Efficiency Vermont. I'm joined today by Bill McClay and Laura Bailey of McClay Architects, and Craig Simmons, an energy consultant at Efficiency Vermont. The focus of today's presentation is on a feasibility study completed earlier this year by a group led by McClay Architects to provide realistic costs and savings numbers across a range of building types and to be looked at various building standards. Bill will first provide some further background and context around the concept of net zero and the thinking behind the study. Laura will then walk us through the net zero energy feasibility study itself, including the data developed and the results. And Craig will wrap up with a look at Efficiency Vermont's initiatives and activity around net zero projects. Before we start, I should mention that we do have everyone on mute, but would like very much to get your questions, which you can type in the questions area of your GoToWebinar sidebar window. We'll plan to monitor those and get to as many as we can at the end of the presentation. We also have just a few questions we would like to ask the audience during the webinar, and I would like to start with two quick ones to help us understand who is participating today. So I'm going to put the first one in place now, and that should come on the screen now. And we'll give you just a little bit to choose one of the 5 options there. And we'll close that down in just a few seconds to take a look at the results, which we'll share with you. So we're still getting a little activity on the entries. We're going to wind it down, and I appreciate your input. We're going to and just looking for, again, a little bit of who we have with us today and what the amount of activity you've had with net zero or net zero ready projects. So I see the answers coming quickly. And we'll give it a second here just before we close it down. Just about there. And that should do it. About 90% are applying, and we'll share that one. Just to give everyone an idea as well. But a pretty good variety, and that's very helpful. Thank you. So about more than half without direct involvement, and some amount with everyone else. Usually 1 to 2, it looks like, is the highest number. So we'll go ahead and move ahead then. Thank you. So with that, we'd like to begin, and I would like to introduce Bill McClay, the founding principal at McClay Architects, and also the author of the new Net Zero, which was published last year. Bill, I think I can give you the, oh, you have the, yep, I think you have the controls now. Thank you, Bill.
Thank you, Paul. So this is Bill McClay. Glad to be here today. So we've been doing work in net zero for in high efficiency buildings for a number of years. Our first slide is, as an architect, this is a slide that I often use in terms of how buildings and people are interconnected. Obviously, also buildings and energy are interconnected. We build our buildings and then we live in those buildings, and we don't have much opportunity to change them for a long period of time. The other quote that I like is Einstein's quote is that if we keep doing things the way we used to, we're not energy that it consumes on an annual basis, and that energy is renewable energy. So some people may think of net zero back in the from the era of the 1970s and energy and independence, where all of us are going to try and be in our own buildings that are energy independent. I think net zero, for us at least, is something really looking more globally and how do we change the planet, and how do we think about buildings interconnected to cities, communities, and buildings as well. So one of the distinctions that we make is the distinction between net zero ready and net zero. Basically, in terms of net zero buildings, you have the loads in the buildings, the lights, the plug loads, the energy consumption in the building, and then you power that with renewables, and a net zero building then produces more energy than it consumes. But an important part of that is the net zero ready part of the puzzle. So all of us know the fuel mileage of the cars that we drive, but very few of us actually know how much the fuel mileage is of the buildings that we're in. For that, the term energy use intensity is what's being used, or just energy intensity, or EY. It's the amount of energy consumed per square foot of building. It's a metric that then you can compare to from one building to another and have an assessment of how your building is performing. And for us, that EY number is really the foundation of net zero. So in this slide, we look at the glass building with a ton of energy consumption, and it might not take all of the PVs that are shown in the desert to power the building, but it brings up the question of how do you balance energy conservation with generating the photovoltaics to generate renewable energy. There really are three different pieces of a net zero building. The first is energy conservation, reducing the energy loads, the EUI of the building. The second is high efficient systems, which typically for us are air or water source heat pumps. And then third is powering with renewables, which is typically with solar PV. There are two ways to be looking at the energy intensity numbers. One is as a performance metric. We typically, typical buildings might be at 60 to 90 kBTUs per square foot per year, and net zero ready buildings are typically down in the 10 to 25 range. In terms of prescriptive measures in the more northern climates, that typically comes down to R60 roofs in the envelope, R40 walls, R5 windows, and R20 in below grade insulation. And then really critical is minimizing the air infiltration, and we calculate the air infiltration based on the surface area of the building and look for 0.1 CFM per square foot of above grade surface area tested at 50 pascals. So why are we looking at that? I think everybody probably on this call pretty much knows that. It's obviously around climate change and how do we create a planet where that's not an issue. And energy, from our perspective, is important not just in terms of buildings, but it also connects to transportation, to ecosystems, to pretty much everything that we're doing in our daily lives. From our perspective, we are at an incredible time in the history of the planet. We are at a time when there is a major energy transition going from fossil fuels back to renewable energy, which is obviously what has powered the planet almost the entire existence of human beings, and which is where we're headed back to now. And what we're finding is that now net zero is actually becoming the least cost option, less costly than fossil fuels. So next, we have another audience poll. Paul, you're doing that, right?
Coming right up. So if everyone would take a look at this, we're finishing up time on it, but everyone's weighing in, it looks like. We'll just wait a few more seconds. A little more thinking on this one. And we'll go ahead and close this poll now, give you just a second here, and see what the consensus is, or if there is one. So I'm going to So it looks like we've got a big number on our upfront additional costs as we'd expect, but also on overall awareness of the opportunity are the two largest. So I'll go ahead and close that, and Bill, you can continue.
Okay. So we have done work for a long time for NRG Systems, a wind monitoring company in Heinsberg, Vermont. And they have a 70,000 square foot building that is mostly almost about over 90% renewably powered. They own some land, about 50 acres around their existing facility, and said, what would it look like if we were to add more office and industrial use, creating a campus, and actually add residential development, thus looking at a community, a neighborhood, and actually what would it take to make that net zero. So with Efficiency Vermont, we looked at the financial feasibility of net zero buildings above code buildings for this entire project, to look at seeing whether this was feasible of looking at a whole net zero community. So the existing building is about 77,000 square feet of office and manufacturing space. Again, it's about 95% renewably powered. What's proposed is potentially over 200,000 square feet of office and office manufacturing in a campus setting. And then another about 86,000 square feet of residential and single and multifamily development. And we then looked at the potential for that to be solar powered for the entire project, which actually was able to happen on site. Laura will now go into more of the details of the project.
Great, thanks. So I'm Laura Bailey. an office that had open workstations and one with closed workstations, and then an office manufacturing facility. For the comparison, we used the 2015 code, the Vermont Energy Standard Code. We wanted it to be the most conservative baseline possible. So as you can see, the envelope was R25 walls, R15 basements, R49 roofs. We did the air infiltration at 0.5 CFM per square foot above grade surface area. The mechanical systems were propane fired furnaces for heating and domestic hot water and residential, and the commercial had the propane fired heating and cooling units on top with demand controlled outside air with no heat recovery in the ventilation. For the net zero ready standards, as Bill described, we have high efficiency envelope. The mechanical systems were air source heat pumps. The ventilation were HRVs and ERVs. The domestic hot water was a heat pump unit for the residential units, and the commercial had electric resistant domestic hot water. And then there was PV sized for each building or each unit to provide enough renewable energy on an annual basis to cover their loads. We assumed $3 a watt installed cost based on a quote we received in the fall for our area and typical installation costs. So then in order to determine the financial analysis for this feasibility study, we had a number of inputs. The first being annual energy consumption. This was determined by using an hourly energy simulation that Andy Shapiro from Energy Balance worked on. The second input was the additional capital cost for those energy efficiency upgrades to go from code to net zero ready. These capital costs were generated from Huntington Homes increase, and we also include what we call the solar plateau. So after a period of time when renewable energy becomes cost effective compared to fossil fuels, people will make that switch over, and therefore fossil fuel prices will not continue to exponentially grow. So in this case, after year 7, the electricity and propane costs did not increase each year. We started with the electricity cost at 15 cents per kilowatt hour, and propane was $3.08 per gallon. These were Vermont fuel prices in the fall of 2014. So the annual energy consumption, again, these numbers were generated from Energy Balance. We looked at each building type on an annual basis and what they used. The left column shows the code building, and then to the right of that is the net zero ready building type for each of the residential units. And the commercial energy consumption on an annual basis here is shown for the open office, the closed office, and the office manufacturing. Again, for the code buildings on the left and the net zero building on the right for each grouping. So when we show these in EUIs for each building type, the energy savings on an annual basis for each of the types is 57 to 74% better than code. And then we also looked at the overall community energy consumption. So we took the EUI for each building typology and multiplied that out over the total square footage for each type, and generated an annual energy load for the code community or a net zero ready community. And then we generated what the PV size would be needed to offset those loads. And for a code community, it would need a 5.8 megawatt system, and for a net zero ready community, a 2.3 megawatt system would provide all of the energy needed on an annual basis. We looked at where on site that PV could be located, maximizing carports and rooftops, and then some additional ground-mounted arrays. So then we got into the incremental costs for the code project, or the net zero ready above code. The residential cost analysis came from Huntington Homes, who's a modular manufacturer here in Vermont, and they are producing high-performance homes as well as code homes. So we were able to get actual data from their facility as to the incremental cost to go to net zero ready. For the single-family homes, it comes out to $16 per square foot additional cost, which is 12% of the project cost. And then if you add PV onto that, it increases to $31 per square foot, or 20% of the total project cost. For the commercial cost estimate, Jay Morrissey did the analysis of the code buildings and the net zero ready buildings, and the offices come out to $9 a square foot additional cost to be net zero ready, and that's a 7% of the total project cost. And again, if you add PV to make it a net zero project, it would be $22 per square foot, or 16% of the project cost. And in relation to this, we also looked at what the open office versus the closed office would cost. And by finishing and partitioning, adding controls and mechanical systems, a closed office came out to $24 to $25 additional per square foot over an open office layout. And so just from that quick analysis, you can see that if you go from a code building to a net zero ready building at only $9 per square foot additional cost, you can more than account for that if you go to an open office layout versus a closed office, and actually make the project cost less overall. So then we went to our financial analysis, and within that we generated first-year ownership and operating costs, as well as cumulative capital operating and finance costs over the duration of our assumed financing terms. So we'll start with the residential portion of the analysis, the single-family homes. These were generated from Huntington Homes. They're designed for a small single-family residential unit that's 1,600 square feet, has 3 bedrooms, 2.5 baths, and assumes 4 occupants. The multifamily duplex and quadplex units are the same unit configurations, just different surface area and exterior wall configuration with a duplex or a quadplex. And these are 1,100 square feet, a 2-bedroom, 1.5 baths, and assumed 3 occupants per unit. And then for the financing graphs that were generated, this is kind of how each clumping is organized. For each building type, there are three analyses that happen. There's a code building, a net zero ready in the center, and then a net zero on the right. The blue show operating costs. The red show financing costs. The purple show the added cost for PV to get to net zero. And then the green are the additional energy efficiency capital costs to make the envelopes net zero ready. So for the residential portion, we assumed a 30-year loan at a 4% fixed interest rate. And for each of the single-family duplex and quadplexes, we assumed that the energy efficiency and the PV could be included in those financing terms. So the red bars here show the additional energy efficiency capital costs in year 1. To make your project net zero, this would be the added finance cost for the PV. These show the operating costs for heating, the code building on the left of each grouping and the net zero ready building in the center of each grouping with the air source heat pumps. And the net zero projects do not have any operating costs because they are offset with the PV production. And then added electric consumption on an annual basis. So from year one, this analysis showed that both the net zero ready and the net zero buildings are cheaper to own and operate than a code building. And that excluded federal tax credits or any local incentives or rebates, which would bring the net zero projects even lower in year one. So then we also looked at it over the 30-year time frame of the financing terms. The green shows the additional envelope capital costs. The purple shows the additional PV cost to go net zero. The red is showing the financing interest over those 30 years. And then this is operating costs. So the code buildings on the left have quite a higher operating costs than the net zero ready, which is in the center. And then over 30 years, the net zero projects are even require more or show even more savings over that time frame, and shows that residential projects that go net zero really are a great benefit and save a considerable amount of money over code projects. And again, we excluded any tax credits or local incentives, but those would reduce the overall operating costs additionally. So we did get some feedback from especially Huntington Homes saying that their clients were unable to finance the added additional costs for the higher envelope upgrades. And so we also looked at scenarios of paying for those additional capital costs in year one and then generating savings over the lifetime of the building. So the dashed lines are showing the net zero ready projects and the solid lines are the code buildings. So after year 10, all of the net zero ready projects cumulative costs to own and operate are less than the code buildings. And after 30 years, the single family home is saving $50,000. So we did look at a number of residential financing options, and here's just a reference to some of those other options. So then we looked at the commercial project, the office, 13,000 square feet, 2 stories. And we looked at 4 configurations: a net zero ready open office, a net zero ready closed office, the code open, and the code closed. The third type of commercial project was the office manufacturing facility, and this was 27,000 square feet. The first floor has a manufacturing warehouse space to the north and 2 floors of office along the south. As you can see in the plan, the south side has the 2 levels of office space. The difference between the net zero ready and the code building is the amount of skylights and daylighting savings that were happening. The net zero ready has 3% skylights in the manufacturing area, and the code building had half of that. Otherwise, daylighting was not accounted for any of the savings in the project because the new code requires pretty substantial controls for daylighting in the office spaces. The commercial financing assumptions were a little more challenging to pin down. It's harder to get a commercial loan that lasts longer than 5 or 7 years. But so we did use some conservative financing terms to look at a 20-year variable loan rate for those added additional capital costs. So it starts at a 4.6% and increases 2% every 5 years. So by the end of the 20-year loan period, the rate is 10.6%. So for the first year operating and ownership costs, the closed offices in the center have the additional financing costs to make it a closed office. So those are shown in the center bars. The next bars are showing the energy efficiency financing costs. And something to note sort of throughout this commercial analysis is the office manufacturing facility had quite a large energy efficiency upgrade cost because it is a very large envelope for a 1-story manufacturing area. And as you'll see in the analysis, that was a challenge given the square footage and the energy reduction did not quite offset those added costs for the envelope. The light red bars show the additional financing costs for the PV systems for each building. These bars are showing the heating costs for the code and the net zero ready, and then the added electric costs for plug loads and ventilation for each of the projects. And as you can see from year one, the net zero ready offices are much lower cost to operate than the code buildings, and the net zero buildings are slightly higher because of our assumed financing terms. But if you apply any of the local incentives or federal tax credits, the net zero ready building would be cheaper to operate than the net zero. The net zero building would be cheaper to operate than the net zero ready building, starting from year one. And then again, we looked at it over the lifetime of the loan, which in the commercial case is 20 years. So the center green is showing the added costs for closed offices, the added cost for the envelope and mechanical upgrades, the added costs for PV, financing of the closed office portion, financing for the added energy efficiency costs, financing for the PV, and then operating costs. So again, adding the federal tax credit or any local rebates would reduce the net zero operating and ownership costs to below the net zero ready standards. And in both the open and closed offices, the net zero ready is much cheaper to operate than the code buildings. But as I had noted before, the office manufacturing, the code building, is actually cheaper to operate than the net zero and the net zero ready based on our financing terms. But we did explore other options for an SBA loan or local incentives and how that would impact the net zero construction of the manufacturing facility. So if you look at cumulative costs with incentives and rebates, then the net zero option does become a very viable and smart choice. So this is showing just cumulative costs over time for the commercial projects. As you can see at the top, the red is the manufacturing facility, and it's showing a negative savings of $100,000. But both of the office buildings are saving close to $300,000 over the 20-year loan period. Again, we looked at a number of different commercial financing options, and it will vary based on your actual projects. But here's some resources to start to investigate other options for longer-term financing loans for commercial projects. And then we applied these to the overall community as well. So for the residential portion, this is the cumulative 30-year costs for the code, the net zero ready, and the net zero residential. This shows the PV costs, the financing costs, and then the operating costs. So you can see the entire residential community would save $3 million in ownership and operating costs compared to a code community. And again, the tax credit would reduce that even further, or increase the savings. For the commercial community, this is showing the added costs for the energy efficiency upgrades, the PV, financing, both of those added costs, and then the operating costs. So the net zero ready saves over $3.3 million over this 20-year loan period. And if the federal tax credit's included, there's upwards of $4.8 million savings over those 20 years compared to a code community. So overall, the savings for a net zero community over a code community would be upwards of $8 million over those 30 years. So this brings us to the overall lessons from this feasibility study, and we found that building type really does affect the cost and the return on the investment. The financing options are also a huge impact for generating savings. Rebates and incentives do make a difference, particularly for the commercial industry. The federal tax credit for solar is sunsetting at 2016, and so that could start to impact some of the net zero options. And as noted before, sometimes appraisals or borrowers do not typically value the net zero ready construction as an added cost to be financed, so that can be a hurdle. As well as fuel volatility, there are very low current costs of fossil fuels, lower than when this analysis was performed in the fall, so that would impact first-year operating costs. But overall, if you look at a longer time frame, it should have less of an impact. And we did use a 4% interest rate for the residential, which is the current rates, but those are likely to rise into the future. So for the residential, the owner-occupied buildings are an excellent investment to go to net zero. The cost was only $13 to $16 additional per square foot. And air source heat pumps are very low and established and available in the marketplace today. The commercial lessons that we learned was the net zero ready offices are a very good investment over code offices. The office manufacturing facilities are cash flow neutral, particularly when other incentives or financing options are explored. The open offices are cheaper to own and operate than the closed offices. The cost for air source heat pump systems seem variable and changing depending on the installers and comfort of those systems. Longer-term fixed loans are available, but it depends on who the ownership and the structure is of the commercial projects. And that the additional cost to go to net zero construction is only $9 to $17 per square foot additional. So with that, I'll pass it back over to Paul for one more audience poll question.
Okay, and this one is just our last poll. Okay. So this is really about forward activity and action that's needed. And we realize you might want to choose more than one, but we've asked just to pick one, and we can kind of get an idea of where people's leanings are on what's most important. We realize it's sort of a multiple. So we'll go ahead and wait a few more seconds to let you find. Yeah, we're still getting some coming in, so I'll give you just another 5 or 10 seconds here. And I think we've got pretty good participation there. So we're going to go ahead and close that down, and we'll take a look at what everyone thinks. And I'm not surprised that we're fairly evenly spread across there. Okay, great, thank you. And I'll go ahead and hide that. And this is Craig Simmons from Efficiency Vermont.
So we wanted to talk just briefly about Efficiency Vermont's motivations for supporting this study and getting this work done, and how we plan to use that information. I mean, essentially, I think our sort of drive reflects one of the earlier polls in terms of, you know, having upfront costs, and that seemed like a hurdle, and also just general sort of education and information that's out in the market. So, you know, by having this data from the study, we can now start to use that and go into our customers and help them understand sort of the long-term impacts of doing a net zero ready or net zero approach to things. And we have, the study is very Vermont specific. I think some of the questions that have come through reflect that aspect of it, where we're really looking at the climate up here and things around here, so that when we look to present this information in the Northeast, we have something that's very relevant. There is net zero information available for other climate zones and other regions, and we really wanted something that sort of reflected the customers in this area. And then, also this now gives us a whole nother set of information to help us in really, providing information to new construction projects and give them information to help assess their costs. Since we don't have, there aren't a large number of net zero projects that have been completed, we don't have good data on completed projects. And so we hope to use this as a way to sort of fill that gap while we have projects in process, and to help them encourage more projects to jump in and pursue this. So we can, and as that happens, we'll start to add to this information with real project data and sort of just expand the knowledge, and hopefully then, and through that address some of the things that Laura brought up, such as, the variability in costs in different systems and things, and start to be able to see how that plays into there. And then, of course, this webinar is a perfect example, and we've done this presentation in other places where it's just, help educate the customers in this area and around the region about how to do this and what the good approach is. And then just a brief summary of sort of, how we're using this and how we're trying to push that in Vermont. The primary way we're using this on the commercial side is we have a net zero energy pilot program. And again, so this, we can now lean on the feasibility study combined with data as we get it to help push more people or convince more people to head into a program like this that, includes a memorandum of agreement that has some commitments to do some things like energy modeling and commit to certain performance levels that people, sort of, I guess, amplifies that fear of upfront costs. But now we have some data and some information that we can start to share to be like, help them understand what the long-term benefits are in going into a program like this. And then through this program, we have probably a dozen or so projects in this program right now with very few completed, and we can start to collect data on these going forward and have a much more robust presentation of information. And then expanding beyond that, we also have a high performance homes program, which deals with the residential side. I think, this program has, the hurdles aren't quite as large. I mean, as is shown in the feasibility study, the benefits tend to be a little more obvious. We're having much better success in a lot more number of projects in here. And we actually have really good data on the home side of things in terms of performance and so on and so forth. And then for this year only, we have a deep energy retrofit to start and try to really evaluate how do you get at this from the existing building side, which is obviously a big factor in the grand scheme of things. And so we have a small pilot program with really large incentives targeted at really trying to encourage unique approaches to doing this on existing buildings. And that program, there's no more applications being accepted for that. But the goal there was, let's not put a lot of strings on it. Let's just let people figure out how to do it. All they have to do is meet some basic performance requirements and, and sort of report in throughout the process to show that they're working towards that. And the reward is a very high incentive level. So that's about it. I don't want to, we don't want to take up too much time there. We want to move on to questions. And so we have a large amount of time now available to hopefully get through a lot of these questions and get a better understanding of the specific concerns from this audience. And and just to wrap up here, this study is available on our website. So this link, and I think there'll be other links coming out afterwards. I'll let Paul speak to that, but this information will all be available on the web after the webinar.
Great, thanks, Craig. Yeah, just to cover and there have been a few questions about access to the report. There's actually a summary report and a full report that are on our website. That link there is in the handout that is on your GoToWebinar sidebar. If you open up the handout window portion of it, you can that's a very small PDF file with contact information and the link that you see on your screen now. As we speak, and we will be adding a recording of this webinar on that same page, and we'll also put this slide deck there as well. So all the information will be really in that one location. It's really easy to find by going to efficiencyvermont.com, and then the About Us tab basically has a number of white papers and information like that. So that's what that link represents. So we have a number of questions that we'd like to get to. Thank you for all your input. I'll sort of start, and we'll just sort of pick those up as we go. Few specific questions about the report or presentation was, first one, and this might be for you, Laura. I didn't see any cooling energy breakdown. Does the heat include cooling? And I think that's referring to the call-outs of where you either have propane or electricity. You might describe where the cooling is included.
Great. There is cooling in the commercial projects. The residential, we assumed no cooling given our climate here in Vermont. And the annual energy graph does break those out from heating, cooling, lighting breakout. And then some of the analysis for the financing portion just clumps it based on utility data. So I'm not sure.
Well, I think part of it is that in the presentation of the financial analysis, what people may notice is, so the heating has to be called out because in the code building, that heating is a propane heating source, which then switches to an electricity and the air source thing, and the cooling in the commercial graphs is just lumped into the electricity on those graphs.
Great.
Okay. Let's see, how does the financial analysis figure when you consider some of the solar companies that provide a turnkey system and they supposedly are paid out of the savings on your electric bill? So maybe you could just comment on the assumptions about the installation of PV.
Sure, I could take a stab at that. This is Bill McClay. Yeah, we discussed when we set up the study how to address that. But in terms of looking at net zero and the financial case for net zero, I mean, the renewables part right now, given that in most states there are power purchase agreements available, and in general those power purchase agreements allow the individual property owner to be purchasing renewable energy that's generated on their site but installed by somebody else. So I think that only really improves the case in terms of solar. If you don't want to do the capital outlay, you still can end up with net zero building.
And in the case of the analysis, the net zero ready building would be a very similar comparison to a project that has a PPA, since they would still be paying their electric bill to their solar installer in that case. And the financing may be slightly different, but it would be similar to that middle case for each of those projects.
Okay, let me just find. So there were a couple questions about operating and maintenance costs and whether they were figured. Question specifically about PV with operating and maintenance costs, so that might be one that's different, but maybe you have something else that's different on the code side.
We didn't look at it anywhere. I mean, in terms of the PV, those costs are relatively small. I mean, the PV itself will degrade over time, but actually relatively slowly, and then the significant potential operating maintenance cost is the inverter. Probably will need to be replaced, but in the overall scheme of things, it's not that expensive. But the answer is we didn't include that anywhere.
Okay. Here's a quick one just on the square footages of the homes that were analyzed. Could you just go over the size of the buildings? Yeah, and the homes.
Yep, the single-family homes were 1,600 square feet, and that's 2 floors of living space. And in all of them, the basement was unfinished space, so that was not included in the square footage. And the duplex and quadplex units were 1,100 square feet. Again, two stories of living space.
Okay, so I'll just read this one here. From the quick look at the plans on the screen, it looks like you have some passive solar orientation. The north windows are smaller than the south windows. Have you had any issues with egress code compliance on the smaller bedroom windows? I have found that egress is requiring much larger windows than we would like to see on the north side.
Well, we didn't analyze. These were plans and elevations directly from Huntington Homes for projects that they have built in the area. It seemed like the east and west windows out of those bedrooms would be egress windows, but it's not something that we adjusted in the plan.
And actually, I mean, in our practice, I mean, we obviously are putting in egress-sized windows, and in terms of making them egress-sized, I mean, a bedroom obviously wants a certain amount of daylight and view, and you're going to want that much glass for daylight and view. So I don't see any conflict with the energy goals and the egress goals.
Okay. Let's see. Do you typically look at the GWP of materials used in these net zero projects, particularly XPS and EPS rigid exterior insulation? So
yeah, that is something we looked at for the residential portion. Huntington Homes does dense packed cellulose, double stud wall. We do recommend exterior insulation to keep the sheathing at the appropriate temperature so we don't have condensation issues. And we spec polyiso as the polyiso or Roxol for the exterior rigid insulation because those do have lower greenhouse warming potential than the other rigid foams.
Yeah, and just to explain the jargon for some of the listeners may not know what GWP is, but it's global warming potential. So it's what are some of the environmental impacts of different types of insulation and installation systems. So that is something that we do evaluate, with our clients and do consider in design of the buildings.
And another aspect of that that came up, and it's described in the full report, but for the commercial projects, the NFPA fire ratings for exterior foam has become more stringent, and so for the manufacturing and office buildings in the study, we used metal panelized systems of varying depths to get the exterior wall envelopes because those have been rated systems and can be available.
Right, in commercial buildings, it's more challenging to get the higher R values that we've been using in the walls, not so much in the roof. Use polyiso is not a problem, but in the wall assemblies, the fire code there's compliance issues. So we have, using the metal panels, they are a rated system, and that way we still could achieve higher insulation value, which otherwise you're limited to the thickness of rigid insulations on the outside of steel and concrete buildings.
So here's a general question about the construction and the standard chosen. How close to passive house were the net zero ready residential and commercial buildings, energy and envelope wise?
I don't think we evaluated it compared to passive house, and passive house just updated as well.
Right. I mean, what we're finding is that our recommended levels for our climate are actually becoming pretty much where the new passive house standards seem to be heading. Compared to the past passive house standards, then this is significantly less than than what the passive house standards are in terms of the insulation levels. In terms of air infiltration levels, these numbers we calculate slightly different. They do on volume, and we end up doing it on surface area. But if you sort of look at those two, we're actually reasonably close, but not quite the same.
And another piece in terms of how we've reached the R40, 60, 20, and R5 windows was also in working with Andy Shapira at Energy Balance and determining the cost effectiveness of a little bit more PV over a little bit more insulation. And so that's where McClay Architects as a firm has also come to find the best cost-benefit ratio for balancing those two variables.
Which again is actually, I think, where passive house is headed to, beginning to balance those as well.
Right, and that was one of the big updates to the 2015 passive house standards that they really did. They used the platform that I think available through NREL to really evaluate that cost benefit, and the result was sort of coming more closer to a standard like this when you really looked at cost benefit and going just a little bit past that cusp of where that cost benefit starts to balance out.
Maybe this can just be a clarification for some. The question is, do you consider ground source heat pump and air source heat pumps as renewables?
No. We consider them as high efficiency electric energy. So that then the electricity can be provided by PV when you look at it on an annual basis. Obviously, on a winter day in Vermont, the power is not coming from the PV outside your building. And I think that, in terms of particularly the ground source heat pump, is a common confusion. People call it geothermal, but geothermal is really what you have in Iceland, and what you're doing is extracting energy out of either water, ground, or air in all those other scenarios. And so that's what we're doing.
Yeah, an interesting aspect that actually relates to this about this approach is that to using an air source heat pump in our climate is actually hasn't been a long time that we've been able to do that and not have a backup system to use on those really cold days when that air source heat pump can't actually meet the demand and it is -20. And really, in order to make that all work, you have to go to this really high performing envelope, so that because there are going to be hours in the year, and there's not that many, but there's a few where that air source heat pump isn't going to be able to meet the exact set point, but if the building's tight enough and insulated enough, it's going to coast very easily through those periods.
So we have time for maybe just one or two more questions before we finish up within the hour plan, but I think there's a few questions here which are sort of focused on lower fuel costs and how would the assumptions in the study play out. And so the one, for instance, is there a tipping point where the financial case does not pass? I believe you mentioned the cost was 15 cents per kilowatt hour. If this cost for energy were 10 cents, would you anticipate this would pass financial tests? And there's also some other references to lower propane or natural gas costs. So maybe just a comment on the assumptions and what other assumptions would how sensitive the results would be to other assumptions.
So we did make this based on Vermont, and I think these assumptions that we have are not too dissimilar from most of New England. But if you go to the Pacific Northwest, where hydro is really cheap, or other parts of the country where coal may be making things really cheap, obviously that does change the numbers. We couldn't cover absolutely everywhere, but I think our goal in this was to develop a process that can be used in different locations to make an assessment of what actually is a good choice in that specific location.
Okay, and so it said, I'll just finish with this one here. Have you done any analysis whether it would be feasible to have sufficient PVs for energy usage for a high rise? No.
There actually, I was reading that there are some high rises that now are being proposed. I think that gets into the whole definition of net zero, and I think our perspective is we need to make net zero cities and net zero countries and planet. And that means that really what's, I think, most important is the energy intensity numbers and getting them down to net zero ready standards. Once they're at net zero ready standards, in some locations, obviously, if you can, you're going to put the solar on the building where you're doing it or on the site. But from our perspective, it's equally valid to go and participate in a community system that's off-site. Or actually, if your site has extra capacity, to develop a larger community system and then invite people off of your site there. And obviously, the utilities are beginning to shift over to renewable. So I think the important part in terms of limiting carbon is really about the energy conservation part and getting the levels of all of our buildings, new and existing, down to where the levels that they need to be at. Then they can be powered with renewables, whether they're on the building, whether they're on that site, or whether they're coming from some totally different location, or even coming from their utility.
Great, thanks, Bill. So I think we'll wrap up now. There's a number of questions we weren't able to get to, and where we can, we'll try and reach back to those who asked them. And there's a comment in several cases that you couldn't see the handout window. Not sure why that's the case, but there will be a follow-up email with the same link that's on the screen here. So if you're not able to find that, please reach out to us. And there's, again, on that follow-up email, there'll be a contact email there, which is mine. But we appreciate everyone joining in and providing so many questions. And thank you for coming. That's it for today. Thank you.